So today's kind of the first day of IS50B for summer. Yesterday we talked a little bit about the organization of the class, went over. But today we're going to talk about our first actual topic. So 50B is a class in which you go beyond the basics, right? In IS50A you learned about making a level and putting things in it and some basic maybe animation stuff and timelines, things like that. In this class, I'm really aiming to give you more of a formal background because there's a lot of very interesting stuff that goes into making games. And you guys have all taken data structures, right? I'm pretty sure all of you guys have, right? You've all taken CSI 41 with me? Yeah, okay, perfect. So there's some data structures for video games, right? And so we'll talk about that and ways of optimizing video games. Because if you make your video game wrong, then your frame rate is going to be terrible, right? Wrong in terms of like picking the wrong data structure or something like that. So we're going to start off with first is a really easy to understand concept, but it actually has a lot of different applications and oftentimes surprising ways. And so the basic idea of what's called a Voroni diagram or a Dirichlet domain, and there's a couple different ways of describing it. Is that you're going to find all the points on the map that are closer to one point than another point. Okay, so for your homework assignment, it's going to randomly scatter cities on a map, and then you have to color the world based on which part of the world belongs to each city. And the rule is a part of the world belongs to a city when it's closer to it than any other. Very, very simple concept. And so what you get is these things. It's called a Voroni diagram, and it basically colors the world based on who owns what territory. You're like, all right, that's cool, I guess. You're like, what's the point? Well, I mean, you can use it. I mean, first off, you can use it to make a map, right? Like if you're going to make a random world or something like that, like you're making a real-time strategy game or some sort of strategy game, you can use it to make a map. But more than that, like it's used in all sorts of like map generation techniques. For example, this could be a water area, and this could be a cliff, and then they do things. They do things to keep them from getting these like really long, narrow, like toothpick-looking regions. And so there's different techniques that people use that maybe we'll talk about in a little bit to sort of stop those things from happening. But basically, if you start with the Voroni region and then you randomly assign water to it, like you can have like a river, like like you could have a river running through this, and then this could be lowlands and this could be higher elevation. And so you could create like a plateaued system where you might have a rule where every plateau can be no more than one higher than the area around it. So if you were to color all these blue, let me save this image. I don't want an SVG, I want something I can work with. There you go. And let's open this in Paint. Okay. And so let's where's the fill tool? Okay. All right. So suppose that we, randomly choose a cell and sort of walk across the map. All right, let's make these not blue so it's a little more. Boop. Make you red. And then these guys we will make blue. There you go. All right, so you can start off with a Voroni diagram, and then you can drag, you sort of start at a random edge, and then walk in a certain direction, and just color all the regions blue, and then you can do things like say, all right, well this area, it's too close in color, whatever. You say this area here is lowland, and then this is a height 1, this is height 0, this is height 1, height 2, height 3, and you can build interesting 3D maps for like Age of Empires style real-time strategy games out of it. And then you apply smoothing and things like that. So rather than getting these little sharp edges and things like that, it forms like a little rounded beach area where the grassland touches the water. And you can actually make very nice looking random maps using Voroni diagrams like this. They're also used in, you can make textures with them. Like using Voroni diagrams, you can make cobblestones. And so if you want to make a dynamically generated cobblestone pattern, you can scatter random seed points, these things are called seed points, and then make the cobblestone the area that's closest to that seed point. And let's see if I can find an example of that. So in this semester, we're going to be learning about all these kind of interesting tricks. They're interesting to me. I don't know if they're interesting to you, but they're interesting to me. That game developers use to do cool stuff, you know. Procedural modeling. So here you can see they're using Voroni regions to make a cobblestone pattern. And it's dynamically generating it. So you don't just have a fixed, repeating, naked director makes an appearance all over Japan. Really? Okay. All right. So it can tile, any surface. And you see how it doesn't repeat itself, right? Like all the cobblestones are kind of different shapes and sizes and things like that. And so, the Voroni technique comes up kind of everywhere. Oh, not everywhere, but it's pretty common. So, that's cool. That looks nice. Yeah. Okay. So, your homework assignment is to implement Voroni. Yep. So, looks like this. Hopefully, Bazookian, you can see this in the car. Hopefully, you're not driving. Yep, that looks like it would save so much time off building. Yeah, that's a really important point. Is that when you're working with textures or materials, the edges usually look really bad, right? And so they're all designed to wrap, and tile. And so what happens is that when you get to the edge of a wall, there's just a brick that's cut off, and it just kind of looks bad, Whereas when you use a technique like that and it dynamically fills it, not only does it avoid the tiling issue is that you get the same square picture over and over and over again, right? Which looks terrible, right? That you don't have to waste all your time trying to solve all these they're not really important issues, but they still kind of look bad, So if you've ever played a game where you see the textures just repeating over and over again, it just looks really bad. The human eye will pick up on the tiling really, really quickly. And so when you sort of dynamically generate things like that, it looks a lot more natural to us too. And so all it is you just scatter random seeds over the area, and then you just color in the areas that are closer to you than other people, and that's a cobblestone. And, yeah. It's a cool technique. And like I said, it crops up everywhere. Or not everywhere, but commonly enough. Okay. So the assignment's going to look like this. After you run it, it randomly scatters seeds, and then it colors the world based on whoever's close, whatever city's closest. Okay. And then you have to print out who is the biggest country in the world. So the conceit here is it's some sort of strategy game, and we're creating random city-states to populate the world. And so Kabul, the K, is the biggest country with 663 tiles owned. You run it again. It picks a different set of seeds, and in this case, Kabul won again. Oh, okay. Check you out. Edinburgh in this time. Okay, so Edinburgh, E, is the biggest country with 611 tiles owned. Okay. And so you can see we're just sitting there randomly generating maps. And like I said, usually when you do this in a professional game, they have various techniques to kind of get sharp edges like this are very unnatural, right? Maybe not, like Colorado is a square, Wyoming's the Four Corners area. Like, it does happen. But like countries usually aren't like needle thin. Like that's, Israel, I guess, maybe, but countries typically aren't like shaped like this, right? Or this. And so in video games, they'll typically have some heuristics or something. We'll talk about a relaxation technique maybe next time, on how to like kind of round them out a little more and make them a little more natural looking. But this is all you have to do. So I'm in with a Wi-Fi of a store in LA. Okay. So Bezikian, do you have any ideas how you would implement this algorithm? So I think I'm giving you the colors and the starting cities. Let's find out what I actually am giving you. So, yeah, so basically there's a city class that generates a random color for itself. And it has a row and column that's its location in the world. It has a name. So this gets how big the current screen is. So it's going to fill in the current screen. And okay. So do I not have a list of names for you? Maybe not. Okay. So what you're going to have to do is come up with an algorithm that will figure out which tile is owned by which city. And you have to print the thing to the screen. So I'll go over how to do colors and things like that a little bit. Do you guys have any idea how you can figure out what city owns what tile? No, don't worry about the color for now. But just like, let's say there's 20 cities in the world, and you're at row 10, column 30. How do you figure out which city owns that tile? So it's like you compare each point to the city with a distance from it. Yeah, so you could do that. You could do a Pythagorean theorem, right? And just be like, Pythagoras, boom. You're like, hey, look, I'm closest to Chicago, so the owner of me is Chicago, right? So there's a 2D vector that holds all of the tiles, and each tile has the index of the owner. So there's a vector of cities. And so if Chicago is city 12, then you're going to set row 10, column 30. Sorry. Column 10, row 30. I have to make sure my hand moves the right way. Row 10, no, wait. Column 10, row 30. Yeah. Its owner to be whatever the index of Chicago is. Okay. And content is whether it's blank or it has a letter for the city on it. So Chicago would have a C there. Everything else would be blank. Okay. I feel like it formed circles if we did it. What's interesting is no. That's actually perfectly fine if somewhat unoptimal algorithm. For every tile, for every city, you compute the distance and pick the smallest one. So if there is n tiles and there is m cities, it is an n times n algorithm, which is not, it's not the end of the world. It's not that. It's bad. It's not that bad, I guess. And for this, there's like, I don't know, a couple hundred tiles, 20 cities. Yeah, modern day computer can handle that just fine. If you're doing something bigger, or if you're not using a tile-based system, then there's actually better algorithms for handling that. So there's like a sweep line. Let's see if I can find an animated GIF of it. Voroni sweep. And so you can see as it goes down. So it goes. I've seen it go left to right also, and so it's a pretty cool algorithm. the end of the day, you have a Voroni tessellation. So, but there's no grid here, right? There's no tile-based system for this, and so they're actually using like geometry essentially they're essentially what they're doing is they're outputting these regions, and so they're outputting the lines. Whereas for us, we're outputting the tiles, which is, is what it is. All right, so yeah, that's Voroni. Let's see, what do you need to know in order to do this? First of all, do you guys know how to do color and things like that on the server? Isn't the code doing it? Is it? Nope. A little bit. I'll give you this part. That turns the colors red, that turns the colors green, and that resets the colors there. But the assignment has you guys using 8-bit color. So 8 bits of red, 8 bits of green, 8 bits of blue. And so that's the color the city is, but it's not actually printing anything. It's randomly giving a color to the city, but that doesn't, you've actually got to do the coloring. Okay. So how do you do that? Well, then main.cc. Okay, so I'm using my read library, I'm using my colors library. So, I don't know if you guys want to guess which one does colors, but I'll give you one guess on it. Okay, so, okay, so we're going to read a string in from the keyboard, and then if you want to make it red, you can just do that. And what are you complaining about? Okay, thank you. Finally on the server, cool. Yeah, and so the most basic way of doing colors, there's actually an enum set up that for red and green and blue and things like that. So if we were to compile this code, C++, main.cc, and run it, type your name, Bill. Bill comes out in red. And notice that now the terminal is all red. So, resets the colors back to normal, whatever your default color scheme is. Okay. My name is now Bob, so it prints out Bob. Yeah. Bob comes out in red, and then it goes back to the normal color. Access granted. You're in. All right. So this is not good enough though for this homework assignment. For this homework assignment, you guys are gonna have to output 8-bit color. Okay. And you can actually do like pretty nice things actually in 8-bit color, right? Like if you if you want, you can actually render images inside of the terminal. If I were to shrink the font size, this picture would become more and more clear. The smaller I made the font size. So change settings. Let's change it to 1-point font. And so this is actually printing. It's going through an image of Kyoto. It's the Gyan district in Kyoto. And it's reading all of the color values from the image, and then it's printing them to the screen. And I'm going to show you guys how to do this in a second. But it's actually rendering a full a full millions of colors image inside of Putty, which Putty was not designed for this. This is a text terminal, and it's actually rendering a millions of colors image. This is, I don't know if it's a 4K image or what, but it's a fairly high resolution image in full color, and you can see it comes out pretty good. You know what I mean? It's slow, but I mean, it's also transmitting over the internet. So There you go. So that is a 32-bit image inside of Putty. And what character is responsible for each pixel? Space. So some people who have done this sort of thing, they'll actually print out characters and try to match the characters to the lines in the image. I'm just actually printing out a space and setting the background color. So I'm setting the R, the G, and the B values of the background color and then printing a space character out. And that's one of the reasons why it's so slow, is because I'm echoing to the screen the escape sequences to change the color, then I print a space, then I print out the escape sequence for the next pixel, and then a space over and over again. And so it is not fast. It's a very inefficient way of transmitting image data. But it's working inside of a terminal, so it's so cool. I don't know. I think it's cool. And what's funny is that Putty will actually barf and die if you try scrolling with something like that up. The thing just lags horribly if you try scrolling the thing off the screen. And so I submitted a bug report to the Putty people saying, hey, by the way, when I'm rendering a 4K image inside of Putty, the performance goes down. They didn't write back to me. Okay, so let's learn how to do that. Okay, so if you want to look at the colors.h, it's found on vim public colors.h, or you can go on to my GitHub if you want to do this at home. GitHub. There you go. And you see I have my colors library there, the read library, which is the thing I'm most proud of in life, other than my daughter, I guess. Is up there as well if you want to download it on your home machine. So it's got some documentation on GitHub, and this is the key thing, okay? And this is what you guys need, this function right here, set background color. And so set background color sets the color of the background. Takes 3 parameters, the red value, R, G, and B, okay? So it takes 3 parameters, the red, the green, the blue. Okay? And they range from 0 to 255. So this little for loop here is going to print out a 10 by 10 square, and the red value is always 0, the green value is some formula of algebra, and the blue value is 20 times I. So every row that you go down, it gets 20 points more blue. You can see it does a nice little gradient like that. As it goes to the right, it gets more green, and as it goes down, it gets more green as well. So it gets more green this way, it gets more green that way, and it gets more blue this way. So you make kind of pretty little gradients with it. And then when you're done, you call reset color, and that sets all the colors back to normal, and there you go. So that's the function. Okay. So this is actually a Monet inside a Putty. How did you compensate to make images when the terminal is not a perfect square? So my program tries to guess the rectangular size of the terminal and samples. If you don't have full pixels on the screen, then it samples it and tries to compensate for it. It's not perfect. There's probably better ways of doing it. But yeah, it recognizes that going horizontally is not the same as going down. So anyway, so you guys understand? So that's the function you need. That's the function you need. You come back up into here, name.cc. Please type in your name. All right. Set background color. I'll set it to 100, 0, 100. So it's 100 red, 0 green, 100 blue. So you notice how the background color changed to purple, not the front, not the foreground color. So if you want to set the foreground color, it's just set color. I can set that to 200. So we'll set it to like a 75% white color. Reset resets the colors back to normal. If you don't do that, then it will leave your terminal in whatever state you had before. So like, if I don't do that, now everything is purple. Type ls. Oh, actually, ls changes the colors. So when you're working with a terminal, things are forever until they're not. So it's good practice to just get into the habit of just resetting the colors back to the terminal default whenever you're done with colors. Okay. Is it an enum in your headers? It is. So if we look at public letters.h, there's some preset colors: red, green, blue, black, white, bold black, bold red, bold green. And then reset is that one. So that resets the colors back to normal. And so set background color, set foreground colors is called set color. Reset color resets the colors also. This tells you how big the terminal is. And so if you write this line of code here, rows will be set to the number of rows the terminal has. Columns get set to the number of columns the terminal has. And that's how you can fill the screen. Move cursor. This allows you to move the cursor around on the screen. Clear screen clears the screen. Show cursor. If you pass in true, the cursor will appear. You see I have a cursor moving around on there right now, a green box. You can turn that on and off. Okay. So you can hide that, which I'd recommend. You can turn on mouse support if you want. We're not going to worry about that for now. But yeah, you can make it so you can click on things and stuff like that. And then there's like non-blocking I/O and stuff like that we'll worry about later. So yeah, you make simple games and using it. Maybe we'll do Pong or something like that. Oh my gosh. There we go. Thank you. Too much purple. Okay. So yeah, the only thing you need for this assignment, I think, is just set background color. Yeah, probably. And and you just set the background color to the red, the green, the blue value of the city you're next to. What else you guys got to do? Yeah, so remember the hypot function in C++ does the Pythagorean distance. That's the easiest way of doing it. If you want, you could do the sweep line algorithm. It's really overkill for this assignment. You then need to print the world. So the world is just a 2D array, and you just go down it, and all you have to do is set the color every time. If you want to be optimal, you can only change the color when the color changes. So you can kind of like remember what the last color was. And so like if you're just going through a purple region, rather than saying set the color to purple, set the color to purple, set the color to purple, which wastes bandwidth, right? You can just remember, oh, the last color I set it to is purple, so don't set the color again until it's not purple, right? So that might be a fun little optimization for you guys to do. And these kinds of optimizations are very common in real life, right? There's absolutely no reason to keep changing the color to purple over and over again, right? Set it once, and then once the color changes to orange or something, then you call set background color again. That's a neat little optimization. I would recommend you guys do it. You'll see how much faster the screen redraws also. Like the screen can actually go, even though it's all text. And if you do that, it speeds up the redraw. Make a system by which you can load, store, and edit the names of the city-states in the world. So you can make a little text file containing different city names, whatever. You guys know how to edit files, it's fine. Yeah, don't worry about number 4, I guess. I was being a little bit ambitious with that one. Basically, I just want you to do a Voroni calculation and then print out which city has the most terrain. Okay. So, yeah. Extra credit. Okay. Yeah. Okay. You don't need to add arms to the snowman. No. Just 3 balls, 2 eyes, and a nose. Yeah. Is there a limit to how many places there can be? Walker... Walker made a lot of cities. Yeah. Yeah, he did. Cities. And he, I think, imported the names from Warhammer. The Marshes of Madness, Blightwater, Southern Badlands, Eagle Gate. Yeah, this looks like Warhammer to me. Okay. Yeah. So, the algorithm works fine with lots of... It almost looks better that way. When they're really small, you get a lot of these kind of like needle provinces. And then for the next assignment, we're going to be doing something called a Voroni relaxation. And for that, it helps clean up these like needle-shaped provinces. So watch these two guys. We got N and an N next to each other, and they're kind of like really thin, awkward-looking provinces. A Voroni relaxation, check this out. You see that? They're a little more natural-looking now. So that's a... Excuse me. That's a common technique. You typically will scatter your points randomly and then do like one Voroni relaxation, which we'll talk about next time. But you can see how the countries look a little better now. You can do more if you want. If you do too many, they all sort of turn into circles. You see that refresh speed right there? That's something about it. If you keep doing Voroni relaxations, eventually they all kind of turn into similar size, similar shape, circle kind of things, which makes for a very boring looking map, right? So, maybe like E, like look at E here. It's like this weird strip of land. So if we do one Voroni relaxation, then it looks a lot more normal. But that's the second assignment. So for now, you guys got 2 days to do this. You don't need to come to lecture tomorrow. Just work on this assignment. I will be here 2:20 to 3:30 if you need help with it, because I know I kind of went over this real fast. But ultimately, the things you need to know are. You're going to need to do print world, and print world's just going to print out this 2D array here. So for every square in the world, that square has an owner, and then that owner has a color. Okay, so it's just going to be a little 2D for loop, doubly nested for loop. You're going to run through every tile and print out the color of its owner and a space, and that prints the map. And if it's the city itself, you print the letter. So every city, the capital has one letter, and so that tile has the first letter of the city on it. Okay. Good noise algorithm. Yeah, it's a neat way of randomly generating things that look kind of interesting. That it's pretty easy to implement. Yep, and so then the Voroni calculation is really easy. For every tile on the map, find the nearest city and set that city to be the owner. and then at the end, compute which city has the most tiles. And so again, that can just be a doubly nested for loop. You just count up how many tiles each city owns. I think I added, no. I think in my implementation, I just had an int for each city, and I just kept track of. How many tiles it had. It was pretty easy. So that's it. That's the Voroni algorithm. Like I said, useful stuff. Not too bad to implement. You guys got 2 days to do this, which I think is pretty reasonable, I think. Yeah. Sounds good. 2 months. Well, it's summer school, right? So in summer school, every day of class of summer school is about a week of normal class. So it's like I'm giving you guys 2 weeks to do this. In reality, it's probably a couple hours worth of work. Yeah. The actual algorithm itself is pretty easy. Just remember the set background color, print a space. Here you go. That's how you print out colors. And then reset when you're done. Is this class recorded? Yes. And it will go up on, I'll put it up on Canvas. So you can review the function calls you need. This header file here itself has documentation. Inside of it has example code. Or you can just go to my GitHub, and the GitHub has documentation as well on it. Okay. That's it for today, guys. And so, like I said, this class, we're going to go into like some of the interesting algorithms, some of the interesting things the tricks, that game developers use, the data structures, because these are the things that really make or break you when you're making a game. Like if your game is beautiful but just has terrible performance, people aren't going to play your game, And so being able to quickly do things, do interesting things, and generate cobblestones and stuff like that. Like there's a lot of stuff that goes into it. And so I'm gonna dig into that this semester with you guys, and then we're also gonna do more Unreal Engine stuff as well, and do some more advanced stuff in Unreal Engine. Okay, does that sound like a fun summer project for you guys? Saving in Unreal Engine. Okay. All right. Okay, sounds good, guys. I will see you in 2 days. I guess what day is this? Wednesday. Okay, yeah, I'll see you guys on Friday, and then we'll do more lecture then and give you guys another homework assignment. Okay. And again, if you guys want to come and rewatch the IS50A stuff, by all means. I know it's been a month for you or so, or a year. Sorry. Okay. Yeah, cool. I'll see you guys later.